Okay, so we're going to do another couple problems. I decided to do a few more problems out of section 7.3 since we're going to skip 7.4 for the test. So hope you're watching the video. We're doing number 16. It's minimum sample size necessary. We also did it in 7.1. So there's two sections that we did this. So be very careful when you're reading the problems. Does it say find a confidence interval, or does it say find a minimum sample size necessary for a certain confidence? So be careful that you read the directions and do the appropriate problem. A recent study indicated that 29% of 100 women over age 55 in the study were widows. So that's a recent study. That's going to be p hat. So 29% would be 29 out of 100. So q hat then would be 71 out of 100, or 0.71. So there's the two pieces for that formula. How large a sample must, how big a sample? So that's the minimum sample size necessary must you take to be 90% confident. So remember, confidence for 90, that's the middle 90. So we got to find the z alpha over 2 using the Invernor program or the Invernor function on the calculator. Most of you have the program. So Invernor, two tail, total area of the two tails has to be 10%, right? So so your z alpha over 2 is 1.645. And it says within 0.05, that's your E. So N equals 0.29, that's your P hat, Q hat 0.71. I just converted it to a decimal. 1.645 over 0.05 squared. Calculate that. So 0.29 times 0.71 times the quantity in parentheses 1.645 divided by 0.05 quantity squared. I got 222.86. We always round up because it's minimum necessary, so you can never go smaller. It's another one of those round up rules. Let's do another one. Oh, let's do part B. No estimate of the sample portion is available. So if the p hat is not known, you use 0.5. So then 0.5 for both of them because those are complements of each other. So everything else is the same. So 0.5 times 0.5 times quantity 1.645 divided by 0.05 squared. 270.6, we'll say at 271. Now here's a case where your answer might be a little different than the back because we're doing different z values than the table value. So it's okay if you're a little bit off. You're probably still doing it right. All right, let's do one more. Let's do 18. Obesity is defined as a body mass index BMI of 30 kilograms per square meter or more. A 95% confidence interval. So we might be running the Invernor program or the Invernor function and getting the z values for that. Is percentage U.S. adults age 20 years and over where obese was found to be 22.4 to 23.5. What was the sample size? You know what? We're going to skip this problem. So skip 18. It's not quite what I was thinking. And let's go to 19. Okay. According to the World Almanac, 35.2% of men ages 18 to 14 meets the U.S. fitness guidelines. How large a sample is necessary to estimate the true portion of men that are fit in this age group within 2.5? That's your E. 2.5%. Let's see, that's 0.025, right? Isn't that 2.5%? I believe to a decimal. I believe so. 90% confidence. Well, we did that already. That was the last problem. So that's the same z value. 1.645. What's left? 35.2%. There's your p hat q hat. So 35.2. What's the complement of that? You can go 1 minus that. 60. Let's see. 65, 64, 8. I think should be, huh? Okay, let's run the formula. 0.352, the complement of that, 64.8. You guys know complements. 1.645 over 0.025 squared. Run the numbers. 0.352 times 0.648 times the quantity 1.645 divided by 0.025 quantity squared. I got 987.6. I got rounded up 988. It's a little different than the back because we're using a little different z value than what they're using, but that's correct. Okay, so you can add in the homework set. This is important now. 15 to 20, and of course skip 18. So that will be included on next week's test, which is going to start on Monday through Thursday. You can pick your day. You can do any day next week, but Thursday by a certain time, I can't remember, sometime Thursday night it has to be done, and it is timed. More info coming on that.